So thanks everyone for being here. Shen, Aneesh, and I are the co-chairs of the OceanUQ working group, and this working group came out of the Ocean OBS 19 conference. The three of us, when we were in the pause panel together, led a session on uncertainty quantification, and it had really great support. A lot of people attended, and we're really excited about the topic and sort of this momentum from the ocean community that we kind of all acknowledge and recognize that uncertainty quantification is very important, and we don't always do a good job of doing it in a consistent way. And so we started this working group with US CLIVAR, and it spun up in early 2020. So like everything, it got a little bit of a slow start, but I think we've made a lot of progress since then. So I'm just going to go over some of the kind of background and then what we've been doing since then. So the overall vision of this working group is to really improve the use of uncertainties in ocean observing and modeling. And so this is, developing strategies and best practices, in terms of how we understand and derive and communicate uncertainties. And part of this is trying not to reinvent the wheel, but number two here is to make existing resources on UQ available to the community. So that's drawing on all of the efforts that are going on throughout the world right now to try to bring those into one place so they're easily accessible to the community. And more broadly, our third objective is the very big one, which is to try to instigate a cultural change in ocean observing and modeling UQ. So really push the community toward recognizing that data is much more valuable. If you're being aggressive, you might say only valuable if it has an associated uncertainty, and also try to get the community to using similar language and techniques so that when I say uncertainty or that it means the same thing to you. So more specific tasks for the working group are first to develop a website for our, to share resources and strategies. Second, to produce some publications. And third, to organize a summer school or workshop or some hybrid of the two. And so quick reminder, this is our team. We have 15 people, and these include oceanographers from all flavors, data scientists, statisticians, and even a science philosopher, which has been interesting and really helpful. Sorry. Okay, so on to our updates. We had a publication in EOS in January. So the three of us plus Mike led this article. And the goal of this was really to sort of announce to the community that we're working on this, and that it's important to think about. Oh, sorry, Shen, you were supposed to present this slide. I'm gonna turn it over to you.
That's okay. That's okay. Do you want to do it?
Go for it. Nope, I can stop talking.
Yeah, no, thank you, Kyla, and thank you everybody for being here. I mean, if it's a short article, and so I encourage you to have a look at it, read it for the purpose of giving us feedback if you want. But we had quite a bit of fun writing this article, and we just wanted to highlight a couple of the key points. Is that we really made a case that uncertainty completes the data themselves, as well as a scientific investigation process. And we took the example of sea level and closing the sea level budget as an example, which is something we haven't been able to do as a community only recently. And then we highlighted, some specific challenges that we have identified in ocean data studies. And those challenges, such as the fact that we are dealing with a non-stationary climate system, or the fact that we can run very expensive models only once, so that we cannot necessarily know the statistical distribution of their outputs. And then those challenges are exacerbated by obstacles, such as problems in communicating uncertainties between various oceanographic insular communities. You know, if you're talking about a satellite oceanographer and you're talking about an in situ observationalist, you know, they may have some different definition of errors, especially when you compare data from satellite and data from in situ, and you have some representation errors, et cetera, et cetera. We also identified a number of gaps in the guiding documents that we're supposed to be using in this community. You know, some of the documents that came out of OceanObs or, you know, the international documents that we should be referring to actually do not necessarily mention error or uncertainty in their requirements. So that's kind of a problem, because if those documents are used to guide funding initiatives, then if uncertainty is not, you know, highlighted as being something important, then it's unlikely to be funded. Nevertheless, you know, there is some hope, and we identified some community-driven solutions, such as, of course, US CLIVAR. Uncertainty quantification is in the science plan of US CLIVAR. And, you know, we highlighted OceanObs, the session that we organized. And of course, we self-publicized a little bit our group and our efforts in this article. And so we also point out to some opportunities in the horizon, the fact that, you know, data science is being more and more used in our field, and data science actually provide us with statistical tools and novel tools to estimate uncertainties in observations and model outputs, etc. The fact that we're also moving towards a more open science, open data type of environment that demystify a little bit, you know, the methods that can be used to quantify uncertainties are very important. And then in the end, you know, this is an op-ed type of article, and so we really wanted to advocate that ocean uncertainty quantification should be present at the proposing stage, the planning stage, and the implementation stage of any present or future ocean studies. And I think these were the key points of this article already. Kyla?
Cool. Thank you. Way better than I would have explained it. The other major update is our website, OceanUQ.org. And this was built for us by the Leslie Smith and other web people at the Consortium for Ocean Leadership, which is awesome because we're not web design specialists. And also, more importantly, because this is doesn't sit on the US CLIVAR website, this website will live on past the working group lifetime. So when our funding runs out, OceanUQ.org will continue to be maintained, or can continue to be maintained. And so this was a pretty big effort to get this up. And right now we have this framework, we have all the pages in place and some initial content, which I'll go over in the next slides. And we're at this stage where we're adding content before we officially release the site, hopefully this spring. And so it's, you can go to this website and it exists, but we haven't been promoting it really heavily until we get it up and running a little bit more, get more content there. So the main content here is blog posts. This is sort of an informal pieces on uncertainty UQ concepts or techniques. So far we have people from the team that have written blog posts, but we're also looking to the broader community for anyone who maybe has an interesting paper or technique that's come out. And the target audience here is oceanographers, not the general public necessarily. So anyone from students to professional high-level oceanographers. We could all use a little education on UQ. And so the next step for this is content. And so if this sounds interesting to you, if you've been working on something cool, or your student or your postdoc has, please contact us. We would love to have new people. It's not a huge effort because it's just an informal blog post and can be short or long. We also have a code section. And so this is, I think this is really cool. It's just a place to share scripts related to UQ techniques. And this is done, it just displays a static view of notebooks that are hosted on GitHub. So it's easy to scroll through and see what's happening and then link to the code yourself if you're interested. And it's a nice complement to the blog. And so I'm just going to very quickly show an example from, this is a blog post that was written by Alec Petty, who is looking at the uncertainty in sea ice thickness uncertainties. And so he has this nice blog post with a bunch of figures and information, and you obviously can't read this, but it's kind of a nice informal style that's enjoyable to read. And then he embedded this code inside the blog, so you can actually take a look at what he's done in terms of the analysis with some nice figures and stuff. And if this is interesting, you can then click to his Python notebook and download it yourself. So I think this has the potential to be super useful. And again, our next steps here are more content. And so once again, if you have some cool UQ related codes that you've developed or have for a paper or a class, please let us know, because we'd love to include those. Also on the site is an ocean uncertainty glossary. And this meets one of our major goals of the working group, which is to help the ocean community use consistent language around UQ. And so many of the terms are from the International Vocabulary of Metrology, sort of an official metrology document. And we have something like 50 terms there, and so we're going to add them as we think of them. There's also a link for readers to request specific definitions, and we'd also like to add some examples, which is always helpful for learning new things. And finally, there's a couple pages with resources. So this is links to external guides and best practices documents and publications that are relevant. And again, we're just working on adding content here. We have quite a few links, but more is generally better. And the papers are kind of organized in this neat format that allows you to filter and look at them in different ways, which I like. And our last slide here is just what we're doing now. So we have, I guess, one more year of funding for our 3-year working group. And so we're really pushing to develop content. Like everyone, our group is really busy and doesn't necessarily have a lot of time to write blog posts. So we've been working on reaching out to the community. I also think that'll give us more buy-in, because this is really the goal here is to have a community website, not just the 15 of us writing stuff and putting it out there. Our major goal for the next in addition to the content is to work on a journal collection. So rather than just doing a single paper written by us, we are running around the idea of doing a special issue to get different people from the community, modeling observationalists, data assimilation folks, specific variable experts, to write articles on UQ strategies and best practices. And then we would, as a team, write the overview article. And this is kind of this is a big project, so we have maybe a 1.5-year timeline for that. And then finally, next year, we plan to hold this summer school or maybe a conference. Again, we haven't quite figured the details out yet, but the general idea is to bring experts together from all of these different communities and work on figuring out where we are, where we need to be, and also developing pedagogical materials so we can better communicate some UQ concepts. If anyone has thoughts on that, we're definitely open to suggestions. So I will stop sharing, and I think we can take questions now.
Great, thank you, Kyla. So do we have any questions for the co-chairs of OceanUQ? Gokhan?
Yeah, maybe I need to go and read the EOS article. I guess I don't have a clear idea of what your definition of uncertainty and its quantification is. In your if I saw what you had in terms of the glossary, you are talking about the definition of variables in terms of quantifying. That I think that's what I read. But in the modeling world, when we talk, I mean, uncertainty quantification has been going on for the last 10, 15 years. But in that case, it goes hand in hand with more like parameter estimations, right? What is the uncertainty in the vertical diffusivities, let's say, that the models use? What's its range? What it should be in optimal settings? But it is not necessarily a single variate analysis. It is multivariate analysis of multiple uncertainties in multiple variables. So it's not just a single one. With the observations, the way that you maybe presented, and maybe I mistook it, it's more like observational error estimates. What is the, I guess, distinction between uncertainty quantification, observational variable definition, and their associated instrumental measurement errors?
I can start to talk to this, and maybe Shane and Kyla, if you can add more. Yeah, Gökhan, I think we are taking like a multi-pronged and a holistic view to uncertainty. We have, I guess that's one reason we haven't like defined uncertainty specifically for just observations or just modeling. I mean, even in modeling, like you said, there is parameter uncertainty, but there's also model uncertainty that goes into data assimilation, for instance, structural uncertainty in modeling. I think what we are highlighting is we need uncertainty in like observations, for instance, both measurement uncertainty, but also like representativeness uncertainty if the observation has to be used for model intercomparison or data assimilation. Then it's not only the observational uncertainty, which might be much smaller than the actual representative uncertainty that's useful for model comparison. So we are trying to define all that in the glossary, like these many different viewpoints on uncertainty and why they need to be quantified for different communities. But yeah, I would say we don't have one single definition of uncertainty and quantification of that specific uncertainty.
I think, personally, I think the way I see it is that everything is an estimate. And, even when you take an observation, it's an estimate from an instrument. A parameter from a model is an estimate, right? And so I think we shouldn't be content with just the estimate. We should also have associated with the estimated values, an estimate of the uncertainty associated with that value, right? So that's basically what we mean. And we would like to streamline a little bit the language so that, we all talk the same language. And I think it's particularly important when we think of the context of data assimilation, where observationalists are going to gather data and they're going to come up with one measure of uncertainty. Sometimes they won't at all. And then, someone who's going to use this data to do some down the line analysis, or someone who's going to assimilate them in the model, is going to take the data and is going to wonder, oh, but what does that uncertainty mean? How do I actually propagate it? Can I propagate it? So I don't really see a difference between observation and model. I think everything is an estimate. And I think, we could just like streamline and be a little bit clearer about what we mean by what. And so, so that when someone produces a data set, then they should not only produce an estimate of the parameter we're talking about, or the observation we're talking about, they should produce as well an estimate of the uncertainty associated with it. So I guess this is what we're trying to push.
Yeah, I guess then in that case, it becomes a bit murky from the modeling side, because in addition to sort of parameter estimation work, as you know, there are lots of now push towards large ensembles, right? They also provide an estimate of uncertainty in the thing. So that's it is quite broad, I guess. Yeah.
Yeah, but I'm thinking, as a non-modeler and as a user of, let's say, ERA 5, I think I'm excited about the fact that the output from ERA 5 gives like an ensemble spread, right, for the reanalysis product. And to me, that's very useful, because I'm like, now I get a stress estimate to look at the response of like the upper ocean, and maybe I can use the uncertainty estimate that is provided with that from that ensemble spread. And that was not available in the previous previous version of that reanalysis. So, we should be doing the same thing with all the observations as well. And so we should dedicate funding to get all these things, and we should, schedule time to derive those uncertainty as well. And it's as valuable as the data themselves.
Thank you.
Mike?
Yeah, a couple questions. One regarding funding, Shane, since you brought that up, do you envision that this would downstream a requirement, in essence, for uncertainty quantification be included in proposals, just as data plans and what's the terminology, showing the impact of the work and all of that, the greater impacts of work? Could you envision downstream that proposals, as well as the way that journal articles are reviewed, would include a common approach across the community, or an understanding that uncertainty quantification needs to be included at the outset of a project and incorporated into the manuscript that results from it?
I think we talk about that in the OS article. We would like to tell people that they should consider uncertainty quantification from the onset of their project. And it shouldn't be an afterthought. You work very hard to get your estimate, and then you go back to the beginning and say, wait a minute, how do I derive an uncertainty associated with it? And then you realize that it may require maybe as much time as you devoted to derive your estimate than it would to get your uncertainty estimate. So you need to realize that from the beginning and budget the adequate time to derive the uncertainty associated with your estimate in the first place. So yeah, I guess people shouldn't underestimate the time that needs to be devoted to derive the uncertainty with any data product or any parameter estimate you're going to come up with your study. So yes, so it should be funded and time should be budgeted for it, I think.
And then a kind of a related follow-up question. In terms of what do you see as the real needs here? I think you mentioned the training program for next year that has yet to be fully scoped. But and I'm leading. This is a leading question because I think I know part of the answer. But are some of the key impediments, or the fact that we don't have this already, because of people's understanding about how to, the statistical approaches that are applied and how to do this effectively? So as people move into this space, do they need better familiarity with tools and all of that, and training perhaps?
Yeah, definitely. And that's one of our main goals is, kind of to emphasize and publicize existing tools, and B, sort of to start to do a summer school where we actually teach techniques and develop some lectures or some materials that can be used more broadly. Because I think that is a big gap.
And I think one thing that should be encouraged as well is basically closer collaboration between data scientists, statisticians, and oceanographer and climate scientists. We don't have to become statisticians ourselves. I mean, we all deal with data. We should be a little bit, but we could collaborate more closely with people that know a little bit more about how to derive uncertainties that we do, as an example.
All right, I saw Fred's hand up next. We can probably go to Charlotte next after. Fred?
Okay, thanks. Thanks for your great work that you're doing with your website and all. I just wanted to briefly talk about representation error, which is something I've thought quite a lot about, and it's like it's a little bit different from other types of error, really, because you could have two absolutely perfect measurement systems, and if they're measuring things at different scales and in different ways, the error actually comes in trying to match them together or compare them against each other. So that's it. It's a little bit different from uncertainty, I guess. I don't know. It's different from measurement error and other types of errors that you could think about.
We have a blog post on this. You're welcome to.
I definitely will. I didn't know it was there, so I will take a look at it. Thanks. I was fascinated to see it.
And thank you, Fred. And I think this is exactly what, we're trying to bring to the conversation, right? Is like, what do people mean by representation error, and why do people that use satellite data, are thinking that, observational institute data have such large errors? But I think it's philosophical, and it's also scientific and geophysical, and you have to understand your measurements and your estimates in order to be able to compare them. So it's part of the conversation, I think.
All right, I think Charlotte, and then we'll end with Gail.
Yeah, so my question sort of goes back to this summer school proposal. I think it's great. And I'm wondering, have you thought yet about who is the target audience, or like how large of a summer school? Can you just maybe share a little bit about what your thoughts are now? I'm wondering, like, students, professionals. I'll leave it at that.
Yeah, I can start. I think we haven't yet had a detailed conversation on this with the working group, Charlotte. We plan to do that over this coming year as we move towards planning the summer school. In our working group proposal, we had proposed either a summer school or a workshop plus like a short hackathon summer school kind of activity. So we need to narrow that down, and if we do go ahead with the summer school, the target audience would be grad students, is what we discussed, grad students and early career scientists. And we haven't discussed the numbers yet, or we do have certain funding, so we would be working within that framework, and also the venue and how much the venue can hold.
We could think of a hybrid format of like maybe 1 day or 2 where, graduate students would be actually, lectured by the people presenting later on during the week or in the afternoon on their specific UQ topic, right? So I think we can do you have any suggestions, Charlotte, about what should be our audience?
I think I like what you just said, and it sort of reminds me of the ASP colloquium format that Aneesh led for was S2S prediction this past summer. I know that was a lot of work for him, but this is also maybe a US CLIVAR supported activity, which comes with all the great support you get from Jenny and Mike. So I know it was a big undertaking for you, Aneesh, but yeah, I think that sounds really great. There are experts in the field who could share their knowledge, and there are certainly students who are pretty interested in some of these topics that I think would get a lot out of this summer school / workshop format. So yeah, happy to talk with you more about that offline if anybody wants.
Great, thanks.
All right, let's go to Gail, and then we'll end with Gokhan. I don't want to go over too long, but because it's a Gokhan, we'll take his question. So go ahead, Gail.
All right, I'll be brief. Yeah, so first of all, I mean, great working group. I think the stuff you're doing is excellent. I was looking at the website, and I really like the kind of the blend that you have between, the glossary, the notebooks, and the sort of blog post ideas. I think in general, one of my comments was, I think the going further even in the kind of the notebook aspect, as in providing tutorials and stuff that people can act with, play with, integrate in their own research, is a great axis for this. And the other comment I was going to make is kind of echoing what's been said, in the sense that in ocean study estimation, we've also spent a lot of time thinking about representation error, and this sort of notion in general that somebody's signal is somebody else's error, and so it's really a matter of perspective at some level. So that's what I wanted to sort of weigh in on, but I think this is a great effort. Thank you.
Thank you. And if you would like to make a blog post on that, someone's signal, someone's error comment, you're welcome to. Because that is the kind of thing we're looking for, right? It's like that I don't know, that's a hard thing to write a peer-reviewed journal article on, but a really useful informal article topic potentially. Thank you.
All right, Gokhan, go ahead.
Yeah, my question was, I don't know whether it's even possible or not. Is there any possibility that machine learning techniques and artificial intelligence techniques can be used for uncertainty quantification in in-situ observations?
Yes, I would say yes. I mean, we are in conversation with the data science working group of US CLIVAR, and there is discussion on like using probabilistic machine learning methods for uncertainty quantification. We haven't. I don't know if there's a specific example that we can give, but there are methods within machine learning to one, like to do mapping, for instance. So if you want to map in situ observations onto a gridded map, and then how do you quantify uncertainty? There are people working on machine learning methods to do that with quantified uncertainty. There are people working on data assimilation also with machine learning. How do you blend observations and models more accurately with machine learning with uncertainty estimates? So yeah, I would say yes, and it's work in progress. And the data science working group is discussing a lot on machine learning AI, and we are engaged with them. Like a few of our members are engaged with them.
Thank you.
Thanks.
All right, so I think that'll conclude today's webinar. I did drop a link to the EOS article in the chat if anyone wants to go to it. So thank you, Kyla, Shane, Aneesh, for the presentation today. Next week, same time, we'll have US AMOC Science Team update by Gokhan, so please join us at that webinar. So thank you everyone for joining.
Thank you.